Okay, then we can start the compilation, where this compilation process will determine if there are any errors in your circuit. It will check and it will tell you if there are any errors, if there are any warnings, or it is okay. Okay, so you can find the compile button, which is here. Okay, the purple triangle button, or you can find them under processing, the start compilation button here. So either one. Alright, so click on the start compilation, then the compiler will start to compile and it will check if there are no errors. So just let it be. You don't have to do anything during this compilation process. Wait until it tells you that everything is done. Okay. Alright, so when it is done, the pop-up windows will come out and tells you that the compilation is successful. Full compilation basically is successful with 4 warnings. Right, so if there are successful and you have some warnings, you can basically ignore them. Okay, but if you have errors, which means here they will be written in red colored writings, so that is the error. There are errors in your circuit, then you have to check them back, and then you have to make sure that the error is replaced with the correct one before you compile it again until you have this full compilation was successful window pop out. Right, so unsuccessful compilation means that you can't proceed to the next step. So make sure you have to obtain the compilation to become successful. Okay. Alright, so once you are here, then you just click on OK to close the pop-up window. Okay. Okay, all the errors, all the warnings you can find here, but for warnings you can ignore them. If there are errors, then you have to make sure you change them. Okay, then now we are about to create the vector waveform file. So basically this is where you are creating the output waveform from the input waveform, which you have to create it by yourself, but the output waveform will be linked together with the circuit that you just created just now to obtain the output. Okay, so the same way how you brings out this block diagram window just now. Okay, so you click on the file button here, look for new, or just this white new button, click on it, and now under the verification and debugging files, you click on vector waveform file. Okay, just now it is the block diagram and schematic for this one. Now the vector waveform file is for the output waveform. Click on OK, then this window will come up. Alright, now basically before you create anything here, you have to make sure you have to set the there are some settings that you have to do before you can proceed. Before you can proceed. Alright. Okay. Of course, first of all, we have to set the end time. Okay. Right. In this vector waveform file, what we are about to do is we want to make sure that this table here can be proven, okay, according to this circuit. Okay, you have drawn this circuit. You just want to make sure this table is proven with the circuit that you have created just now. Okay, so this is where it will be proven here. Okay, now to obtain the input and output ports that you have used just now, which is the X1, X2 and F, you have to follow these initial steps, where you have to go to edit and click on the end time. So this is where basically you'll be setting the end time of your simulation. So for this one, I'll set them to 50 nanosecond. Okay, then click on OK. And as you can see here on the time toolbar, you can only see from 0 until 30 nanosecond, right? So 50 nanosecond is here. So to make sure that you can see them in one window, what you have to do is you click somewhere in the middle here and go to the zoom and click on fit in windows. And now you can see the time toolbar there showing from 0 until 50 nanosecond. So from the start of the simulation until the end of the simulation can be shown. Okay. Then we go to assignment, click on setting. Okay. So here in this part here, or basically you have to go to the simulator setting category. Okay, so here you look into the simulation mode. As you can see, the simulation mode, there are 3 types of them. Okay, which is timing, functional, and then timing using fast timing model. So make sure you change them to functional. Okay, functional means that the software, the circuit you have created will simulate regardless of the time. So there will be no propagation delay time and so whatsoever. So the output will become perfect. Alright. Then click on OK. And then we are about to import the input and output ports to the block vector waveform file here. So you go to edit, go to insert, click on insert node or bus, and then click on node finder. So the node finder window will pop out. Okay, under filter, click on pins all. Make sure this is selected, yeah, the pins all. And then you go to the list button and click on it. So it will find any pins which still not in use, which is the one that we have created just now. Okay, F, X1 and X2. Okay, so now what you have to do is you highlight all of them like this and click on this button here to make sure that it will be selected to the selected nodes. So these 3 is the same one with this node here. Okay, and then you can click on OK and then OK again. Now you can find all of the waveform of the input and output ports. You have F, X1 and X2. As you can see, the F waveform is in forms of this cross symbol, means that it is unknown because this waveform can only be obtained from the given input here. Okay. Alright, so basically what I want to do is I want to arrange the output to be on the bottom part. So just highlight on them and drag them down. Okay, so x1 and x2 is the input. As you can see, both of them are in zeros. Okay, so you want to make sure that you don't have to do any changes on this F waveform. You only need to do for x1 and x2. Okay, so look back to this truth table. We have four possibilities: x1 and x2, 0, 0, 0, 1, 1, 0, and 1, 1. Okay, so 0, 0 output is 0, 0, 1 output is 1, 1, 0 output is 1, 1, 1 output is 0. So that is what we are about to create, this input here for x1 and x2. So what I have to do is just make sure I can show all of the possibilities. So this will be 1, this is 0, 0, this is 0, 1. So x2 to becomes 1, you highlight on it and click on this 1 button. And then the third one is 1, 0. So highlight x1 from 20 nano to 30 nano and click on 1 as well. And then 1, 1 for 30 nano to 40 nano. So highlight both of them, x1 and x2, and then click on 1. So now, as you can see, you have here 0, 0, 0, 1, 1, 0, 1, 1. Okay, which if you compare here, it is fulfilled. Okay, 0, 0, 0, 1, 1, 0, 1, 1. So now this output, you don't have to set them here. So let them be for F. Let the compiler obtain the output automatically from the file here, and this one will be linked together. Okay, so now this waveform file, you have to save them. So click on File, click on Save Project. Make sure the name is the same as well, Test. Okay, click on Save. And then now we are about to simulate the circuit that you have done. Alright, but before that, there is one more thing you have to do, where you have to go to the processing and then click on Generate Functional Simulation Netlist. Okay, so it will generate netlist to link between both of the test file, the waveform and the block diagram. And then it will tell you the functional simulation netlist was successful. Okay, so then you proceed, click on OK. Now you are about to simulate them. So go to processing, you can click on here, start simulation, or this blue triangle. So click on them, it will simulate and the output will be obtained. So here, as you can see, okay, from here, as you can see, this waveform obtained, the waveform of F has already been generated from this initial one that you have done just now. Okay, so F is crossed, and then this one, F has values. Okay, so now you can check 0, 0, 0, 0, 1, 1, 1, 0, 1, 0, 0, 1, 1 is 0, which satisfy this truth table. Okay, so it means that your circuit is correct, as well as for your waveform is also correct. Then your waveform, which you have done just now, prove that the output obtained is the same as how the truth table of the circuit should be. Alright, so that's it. That is the end of this video. So if you are here, means that you are ready. You have already finished this tutorial. Okay, so good luck. use this as your reference for your labs. Thank you and Assalamualaikum.